Hi everyone. So let's start our discussion for today, which is on digital, you know, electronics. Okay, for GATE 2022, right? For GATE 2022 for EC electrical instrumentation and electronics, guys. Okay, so this is going to be our quick revision on digital electronics and what are the important concept you need to keep in mind, before you go for the examination. And your electronics, I think your gate paper is on February 6, right? So you have to be now ready and you have to have the quick revision. You have to give the last touch to this important subjects. From this subject you can expect 8 marks, right? Okay. So what are the important topics which we cover always in digital electronics? You need to know that the very first is the number system. Okay, number system. Okay, number system. And the second one is in the number system there are various things, right? We convert from binary to hexa, from decimal to binary, binary to decimal, or octal to hexa, hexa to octal, octal and all, right? Convergence and complementary number representation we go through, right? Complementary number representation such as sign number representation and one's complement, two's complement, right? So here complementary number representation. Okay, these things you have to keep in mind, because each year you will find few questions from complementary numbers representation, right? And the third is your binary numbers. You need to know about binary numbers. Okay, and the fourth one is binary code, right? Binary codes. Okay, gray code is very important. Okay, binary codes. Fifth one is then we need to know that what are the basics of logic gates, right? Basics of logic gates, right? uh, and or, right, and not. These basic gates you must know what are the basic properties of these gates, so that you could solve questions based on sequential circuit as well, right? When you go and solve flip-flop problems, there you need some knowledge about basic gates and all. Okay. Okay, and then we will talk about Boolean algebra, right? The sixth topic is going to be your Boolean algebra. Okay, Boolean algebra. And then we will talk about SOP. Okay, SOP and PUS. Okay, form representation. These are very important. Okay, from there you can expect few questions. Representations. And then K maps. Okay, K map, coordinate map, graphical way of graphical tool, to minimize any Boolean function, right? And we will talk about combination circuits, right? Combinational circuit. Okay, and you must know the difference between combinational and sequential, right? When you give the input and you expect the output in case of combinational, but in case of sequential, your output depends upon not only the present input, it also depends upon the past input, right? Okay. So sequential circuits, in sequential circuits there are various important concept, right? Sequential circuits. And then important concept is data converters, right? Data converters such as ADC and DAC. Okay, so in sequential circuit mainly see nowadays one of the very important topic, that is delay in combination circuits, right? And sequential circuit. From this topic definitely one question will be there, delay in combination and sequential, right? Delay. So this is one of the very important topic. Last year also question was there, so this time also delay in combination circuits and the sequential circuits. So the concept like setup time, okay, hold time and setup and hold time violation, all those things you must know. Setup, okay, hold, all these. whole time, and when these what are the condition you can avoid setup whole time violation, right? All these things. And the last topic which we will talking about is the semiconductor memories. Semiconductor memories. Okay, so this is the outline for entire digital circuit, right? What I okay what are the ways which I cover, right? So the basics we cover first, right? And then we go to comb, and then we go to sequential, right? So this is what the we always divide digital circuits in three parts, right? The basics, combination, sequential, then converters, right? And then the logic families, or you can say semiconductor memories. Okay, right? So hopefully you might be familiar with the number system and everything, right? So we'll start with the number system and we will see. Okay, and before that we need to also understand what is the difference between digital and analog, all those things, right? So you might be familiar with all these things, right? So I'm not going to talk about anything. Okay, I'm not going to talk about very deep concept, right? We will just touch everything, right? So we'll start with the number system. Okay, so let's start with the number system. Okay, what is number? Okay, up to 10th standard also you might have gone. You need to know what is base. Okay, base of any number system, base, or you call it radix, right? So this is also very important concept, base, right? And what is base? Basically it is the number of digits in a given okay, base means that it is the the number of what, number of digits in a given system, number of digits in a given system. Okay, given number system. Okay, so the example if I talk is the very first example. Suppose this is a base here, base, and we denote it by r. R comes from the radix, right? The very first this later be r. Okay, from r we are representing base as a r, right? So and we'll write here the symbols. Okay, okay, so suppose base is 6 here, right? So how many digits will be there, right? So 0, 1, 2, 3, 4 and 5. So how many digits are there? 1, 2, 3, 4, 5, 6, right? So that's why the base is 6, 6 here, right? And if I talk about 12, right? Suppose base is 12, then we will start with 1, 2, 3, okay, and so on, 8, 9. After 9 you have to write a and b, right? You can't write 10, 11, 12, right? So up to decimal you have to write 0, 1, 2, 3 up to 9, then you have to start with a and b, right? So the base is okay, so base is what? Base is suppose 32, right? So what are the symbols? Okay, symbols here. So if base is 32, then you have to start with 0, 1 and up to 9. Then you have to start with a, b, c, right? Then u and v, right? And suppose base is 64, right? So you have to start with the 0, 1 up to 9. Okay, then x1, x2, okay, then x 53, x 54, like that. Okay, this is one example, right? Which I'm telling you. Okay, so base means that number of digits. Simply, you have to keep in mind that what is the base. They will give you some number system and they will ask can you find the base of this number system, right? So you have to find it. So base is basically the number of digits, and we will try to find base. Okay, we will see how we can find the base. Okay, so example number 2 is okay, suppose this is a symbol, right? Suppose we are given a symbol and we have to see the base. Okay, so the symbol is like 0, 1 and up to a and b. So if you are given a symbol, so if somebody is going to ask you what is the base of this, so you have to see how many digits are there. So it will be 12, right? And suppose this is given as minus 2, minus 1, 0, 1, 2, right? So again, if someone is going to ask you what is the base of this, then you have to tell 5, right? So this is how we we decide base. Okay, right? So moving forward, we will talk about the number system, positional weighted system. Okay, we will sometimes call the number system as positional weighted system. Remember, this is very important point. Number system is also called, right? Number systems are called basically as the positional weighted system. Positional weighted system. Okay, positional weighted system, right? So if the base is r, okay, if the base is what, if the base is r, right, the base is r, suppose. Okay, so how I'm gonna write this? We'll write r to the power 0, r to the power 1, r to the power 3, sorry 2, and so on and so forth, r to the power n minus 2, r to the power n minus 1, right? This is how we write. We might have gone through, you might have gone through, in fact, in your school days, okay, position, the place values and all, right? So number systems sometimes called as a position weighted system basically, and if the base is r, so base to the power 0, base to the power 1, and so on and so forth. And there will be a this radix point. This is known as the radix point. Okay, radix point. So after this radix point, it should be like r to the power minus 1, r to the power minus 2, r to the power minus 3, and so on, right? So there will be four important number system which we will talk about in our digital circuit, right? Important, okay, which is important for gate examination. That is, here we will write system, okay, and here we will write base, okay, or radix. You have to keep in mind radix, okay, radix, and then we will write here the symbols, okay, okay, and which one is used in computer, used in computer, which one we use in computer system, right? Or you can say which number system computer understand, okay, basically which number system computer understand, okay. So you don't have to get panic now because it's the last moment and just we are revising, okay. So you have to revise everything, the concept, right? Needless to solve any new question, just revise and revise and revise and give your best during 3 hours, right? So very first familiar number system is the decimal one, right? 0 to 9, right? So the base is 10 basically, okay, and the symbol, if I 0 1 up to 9, right? And this is not used, okay, this is not used in computer, okay, and your computer cannot understand the decimal number system, right? And the next one is gonna be your binary, okay, which is very important, 0 1, yes no kind of, right? And the base is going to be 2, and the symbols are 0 and 1, okay. And this guy, okay, the binary number system is used, and your computer understand binary number system, okay, remember. And these are, next is hexadecimal, right? Hexadecimal. So hexadecimal is like 16, okay, and the symbols are 0 1 up to 9. Then you have to start with A, B, C, D, E, F, right? And this is also not used in computers, okay. Your computer cannot understand hexadecimal, so you will have to convert hexadecimal to binary, right? And last one is octal, right? So it has the base 8, and you have to represent it like 0 to 7, okay. And this guy is also not used, right? So you have to keep in mind that only the binary number system, only this guy, okay, this binary is used or understood by the computer, right? And you have to keep in mind the base here, right? You will understand what is base and all again once we will take some problem. So number systems are like decimal. This is very familiar number system which we study from the day one when we start studying maths, right? Basic math. Then binary comes into picture, hexadecimal and octal, right? Okay, moving forward, we'll talk about hexadecimal versus binary. We will see, right? Hexadecimal versus binary, okay. Binary 16 base, okay. So remember always that when you want to convert, when you want to convert your hexadecimal to binary, right? So what you will do here, every hex digit, you have to keep in mind this concept, right? Every hex digit, okay, is represented using 4-bit, okay, is represented using 4-bit, okay. When you want to convert hexa to binary, right, suppose 6 is given, right, and it has a base 16, means it is a hexadecimal number system, right? So you have to convert into binary. So what you will do here is that for the 6 you have to write what, how many bit you have to write, 4 bits, right? So you have to use this positional weighted number system 8421, right? So because 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3, right? So now you can represent 6 here, in binary format, that is going to be 0 1 1 0, right? Okay, suppose A16 is there and you have to convert into binary. So what you will do here, A means what, 0 1 2 up to 9, and then 10 is represented by A, right? 10 is represented by A, so A means 10, right? So here 1 0 1 0, right? So this is the base is going to be 2 here, the base is going to be 2 here, right? Always keep this in mind, how to convert hexadecimal to binary. So every hex digits are represented by what, the 4-bit, using 4-bit. So you can see this is hex and this is in binary, 4-bit, okay. Okay, next one is what, next example, if we take, suppose binary is given and you have to convert into hexa, right? So the binary is given, right? Next example, 0 1 0 1, this is binary, base is 2 here now, you have to convert, so it will be 15, sorry 5, okay, right, 8421 you have to see. So this is 0 1 0 1, so 4 plus 1, that is 5. Next is what, 1 1 0 1, right? This is in binary, you have to convert into hexa. It is very easy, right? This is D16, okay. I mean 16 is just a base. And if I talk about octal versus binary, right, this was all about hexa, okay. This was all about hexa, and now we will talk about yes, now we will talk about what, we will talk about octal versus binary, right? Octal versus binary, okay, right. So here you have to keep in mind each octal digit, okay, each octal digit is represented using 3-bit, okay, is represented using 3-bit, that's it, okay. So you have to keep this in mind. So suppose 3 8 is given, right? I mean 3 is there, that is in octal representation, right? So you have to use 4 to 1 here, right? So 4 to 1 means 3, means 0 1 1, right? So how many bits are there? There are only 3, this is in binary now. And suppose 6, and which is given in octal, so you have to represent 1 1 0, right? And this should be written in having the base 2, right? And suppose binary to octal you have to convert, so this is binary here, right? And this format is given in binary paradigm, and you have to convert into octal, so 4 plus 1, that is 5, okay. You can see here 5 is represented in binary 101, right? And this is 100, okay, which is given in binary format, so you have to convert into octal, which should be 4 base 8, right? So this is the basic concept which you have to keep in mind. Each octal digit is represented by 3, okay. So always keep this in mind. Next is suppose let's take one example again, right? So the example number 1 is what, that given the binary format is given here, 1 0 1 1 0 1 0 1, right? This is given, okay, and you have to convert into hexa. You have to convert into hexa. So what you have to do here is you have to group 4 digits, 4 digits you have to group, right? So this is what, so you can convert like 8421, say you can use this 8421. So positional bit system you can use, right? So this is going to be, this is 4 plus 1, that is 5, right? And this is what, this is 8 4 2 1, right? So 3 plus 8, 11, that is B. Okay, so B5 left to, sorry, from this direction, from right to left you have to take. Okay, from right to left. Okay, this is very easy concept, right? And second example if I'm gonna take is suppose 1011 01 1011 01 01. It is given, right, in binary format, and you have to convert into hexa, or you can say you have to convert into octal. In case of octal, you have to group 3 digits, 3 bits, 3 bits here. And if there is no there is less number of bits are there, so you can put 0 here, right? So 0 is not going to change anything. So this is going to be 2, this is 6, this is 5. So it is going to be 265 in octal, right? This is very easy. So I think if this kind of a concept question will be there, you can easily convert, right? But let me tell you guys, the question can be expected from the complements, right? 2's complement, 1's complement. Question can be expected from basic gates, universal gates, right? And question can be expected from delay in combination circuits, delay in sequential circuits, right? Okay. So if I talk about base 5, base 5 number system. Okay, so base 5 number system means what? 0 1 2 3 4 up to 4, right? Okay, 0 2 4. Okay, and then always keep this in mind. And base 10 means what? Base 10 means 0 1 up to 9, right? You have to keep in mind this. Okay, so how can we find that how many bits are required to represent any base? So always keep in mind 2 to the power n you have to equate with the base, right? Base of number system here, right? Suppose the base is 5, so 2 to the power n greater than equal to 5, so n will be equal to what? N will be equal to 3 bits, right? Okay, so in order to represent base 5 number system, you need 3 bits at least, right? 3 bits. Remember, always keep this in mind, 3 bits. Suppose 16 base is there, right? 2 to the power n, and the base is 16, so n should be equal to 4, right? N should be equal to 4. So if hexa is given, so you have to use for each hex digit 4 number of bits, 4 number of bits. This is how we find, always in mind, keep in mind this. Okay. Okay, so in the number system conversion, decimal to any number system, right? So we will see number system conversion. Number system conversion. Okay, so in number system conversion, decimal to any other number system, right? Number system. Second one we will talk about is other number system to decimal. So you have to follow this technique only. This will be very smart way of converting one number system to another number system. Okay, and already we have discussed hexa to binary, but here we will talk about hexa decimal to octal. Okay, but there is no direct conversion, procedure from hexa to octal. You will have to convert first hexa to binary, then binary to octal you can go. There will be intermediate step involved, right? In case of octal to hexa as well, right? Remember always, right? In these two cases are there. Okay, so I hope you might be following this session. This session is basically a quick revision of the digital circuit, right? So let us see how many topics we are going to cover, right? So just we are discussing about number system, right? So we are just touching some important problem and trying to, okay. So let's talk about decimal to other system, right? Decimal to other system. Decimal to other system. Any numbers, right? So for integers, okay, for integers and for fractions, okay, for fractions. Okay, sometimes questions are asked and we usually leave this kind of questions because they are easy, and sometimes we get stuck, right? You don't have to get stuck. Either integer will be given or a fraction, you know, number system will be given in fraction, you have to convert into binary or hexa or whatever, right? So if integer is given, remember always for integers, okay, for integers successive division you have to do by required base. Okay, suppose you have to convert decimal to binary, so you have to divide that decimal number by that base of the binary number system is 2, right? Successive division you have to do, successive division, okay, by required base, by required base, and collect all the reminders. Okay, remember all the remainders, okay, from bottom to top. Okay, from bottom to top. Okay, and in case of fraction, right, in case of fractional part, what you have to do, you have to multiply the fractional part, right? Multiply fraction, right? Multiply fraction by the base, okay, required base. Required base can be binary, hexa, octal, right? Required base, okay, and collect the integer from, and collect the integer, right, from top to bottom, top to bottom. Okay, these are very important concept if you want to convert this from decimal to any other number system. So for the integer part, what you have to do, you have to you know, perform successive division, you know, successive division, and then you have to collect all the remainders from the bottom to top, right, from bottom to top, like this. And you have, for the fractional part, you have to multiply fraction with the required base again. Okay, base can be anything as I told you, and then you have to collect integer from the top to bottom, right? So we will do one problem here in order to the concept get digested, right? So this is 37 given in decimal, right? And you have to convert into binary. Okay, so what you have to do here is there is no fractional part, there is only integer part given, right? So 37 must be divided by the you have to perform the successive division. So 2 is divided by 37 is divided by 2, so it goes by 18, and it gives you the remainder 1, and you have to divide further, so it will be 9 and gives you remainder 0. Okay, 2 4 ja 8 and gives you remainder 1, and 2 2 ja, and it gives you the remainder of 0, and it gives you remainder 1 only, right? It goes, okay, it will there will be remainder, what remainder will be you can say yes, right? So remainder will be what? Remainder will be 0 here. Okay, and now you can collect, right? So, and now you can do like so it will be 1 here, right? So 0 I mean you can say, so here it will be 1, right? So now what you can do, you can collect everything. Okay, so this x value will be, you have to collect from bottom to top, and these are the remainders, right? The remainders after performing successive division. It is 1 0 0 1 0 1 in binary format. So I hope this is clear for everyone, right? So this is how we convert, and in the examination usually we forget because we learn about sequencer circuit, we learn about combinational circuits, and because of simultaneous process going on in your mind for each subjects, right, you tend to forget these things easily, right? So that's why I'm revising here. And okay, so you have to keep this in mind. And in fact, you can use the positional weighted system as well, right? So this is basically 2 raised to power 0, 2 raised to power 1, 2 raised to power like this, okay? 2 raised to power 2, and 3, 4, and this will be 2 raised to power 5. So this gives you 32, and this gives you 4, and this gives you 1. So 32 plus 4, that is 37, okay? So this is how you can also get back your decimal number system, right? Okay. Now let us take one problem where the okay, where fractional part is also involved. Okay, so suppose this is a problem here that is 0.625. This is the in decimal, and you have to convert into binary. So this is the fractional part. So what you have to do here is you can take 625 into 2 and multiply it, so it will give you 1.250, right? So what you have to collect here is this. Okay, so keep collecting. Now you can collect from top to bottom, right? So there is no integer part, so it will be 0 only, and after dot, now after decimal, you have to put after this radix point you have to put 1, right? This one. Now you have to forget about this one. Now 0.250 into 2, right? So it will give you 0.5, so you can collect 0. Now this 0 collect, okay, from top to bottom you have to go. And now what you have to do, 0.5 into 2, right? So this is 1. So once the fraction part becomes 0, you have to stop the process, right? So this is 1. So this is how we convert. This will be in binary, right? I hope this is clear for everyone, how we convert fractional part into binary. So simply you have to multiply with the required base, okay, be it binary base for the binaries, and conversion, or hexa or octal, whatever. Okay, right. Next is the, so if suppose somebody is going to ask you that this is again one example here, 0.1 is given base 10, right, and you have to convert into binary, right? So what you have to do here is you have to take 0.1 and multiply with 2, so it will give you 0.2. 0.1 sorry, 0.2 into 2, it will give you 0.4. 0.4 into 2, it will give you 0.8, and 0.8 into 2 means 1.6. And now you have to collect this 1, right? So this will give you 0.6 into 2, it will give you 1.2, right? So again you have to collect 1, right? So it will give you what? 0.00 okay, and 0, right? Yes, you have to collect 0, then 1, these 1, right? Now 0.2 into what? Here it will give you 0.2, right? So again this is what? 0.4. So it started repeating, right? Okay, you can see 0.4 was there, 0.4 was there, right? So after this 1, so you can put you can write like this, okay, 0.0011, right? Next it will be 0, okay. From here it started repeating, right? So 0, okay, and then 1, 0, 0, 1, 1, right? 0, 0, 1, 1, 0, 0, 1, 1. So what, how you can write this as 0, 0, 0, 0, 0, right? 1, 1, 0, 0, 1, 1, right? So this is getting repeated now. You can write like this, okay. I mean you can write this as okay, so you have to stop the process, okay, you have to stop the process, and you don't have to insanely go on multiplying this, right? So what we are doing here is, in case of fraction, we collect this integer part, right? from top to bottom. Okay, I hope this is clear for everyone, right? So my voice and everything is okay, hopefully, and we are going in the right with the right speed. Okay. Let's talk about next concept. Okay, let's convert from decimal to no, from decimal. Okay, from decimal to octal. Okay, excuse me my writing, because we are doing revision quickly, so this handwriting might go bad as well, right? So you have to, so x10 to x8, how I'm gonna convert, right? So as I told you that you have to again divide, right? So suppose 539 given in decimal, right? So you have to convert into octal. So what you have to do here is 539 divided by 8. So successive, so 8 7 like this, 8 6 ja, 8 7 ja, so be the remainder will be 3, 8 8 ja, right? So remainder is gonna be 3 here, and 8 1 ja here, right? So remainder is gonna be 0, right? And then 8, you can say 0, so it will be 1. So you have to collect like this, so it will be 1033. The base should be, so whatever digits are involved, right, inside this bracket, if the base is 8, so these digits should be less than this, the base, okay, base of the number system, remember always, right? So 1039 we can't write like this. This is wrong, this is wrong, guys, because this digit is greater than this base. Okay, so keep in mind that whatever digits are involved in forming this number, right, that digit should be, each digit should be less than the base. All right, each digits should be less than the base. Okay, keep in mind this concept. Okay. So if I want to convert decimal to hexa, so 4631, this is given in decimal, and you have to convert into hexa. So what you have to do again, as I told you, that 4631 should be successively divided by 16. So 16 2 ja, 8 ja, 9 ja, so remainder will be 7 here. 16 into 18, that is this gives you the remainder 1, and 16 1 ja, right? So remainder 2, and then 16 goes to 0, that is 1. So you have to collect again, it will give you 1217. So again you can see all digits are less than 16. Understand? And you can also see this is what, 16 to the power 0, 16 to the power 1, 16 to the power 2, 16 to the power 3. Once you will add up, you will get 4631 directly. Okay. So other number system to decimal, if I see other number system to decimal, other number system to decimal, right? So you have to just brush up concept, right, based on this session. Okay, I'm not here to touch everything deeply, but here to give you a short revision, a quick revision for scoring 8 marks, right? Other number system to decimals, what you have to do here is for integer, right, for integer and fractions, for integers and fractions, multiply the digit with corresponding weight, multiply the digit with corresponding weight, right, corresponding weight. Okay, corresponding weight, and somehow some all of them, right, some all of them. Okay, So let us take one problem here. The problem number 1 is, that is 27 given in octal, and you have to convert into into decimal, right? So what you have to do here is, this is the base here, right? So base to the power something and multiply with this digit. So 8 to the power 0 into 7 plus 2 into 8 to the power 1. So it will give you what you can see, that is 7, because 8 to any number to the power 0 is 1, and this is 8, that is 16. Okay, so it will give you what, 23 in decimal, right? And the second one is what, that is ab dot 8 given in 16. Okay, and you have to convert into uh, decimal, right? So what you have to do here is, b is what, b is basically 11, right? So b is 11, 16 to the power 0 plus a is 10, that is 16, and dot, after dot you have to write, no, that should be, you have to add again, that is plus, okay, plus 8 into 16 to the power minus 1. Okay, so 16 to the power minus 1, as I have told you, okay, shown you based on the positional weighted concept, right? Number system sometimes called as the positional okay, weighted number system, right? So now you can see 160, okay, plus here this will give you 11, plus this will give you 8 by 16, right? So 1 by 2, right? This will give you 0.5 amount around. So 171 plus 0.5, it will give you what, 171.0 171 in 0.5 in this. So this guy can be converted into decimal like 171.5, right, in decimal. So I hope this is clear for everyone. Whatever base is there, right, you have to take that base to the power 0, 1, 2 and multiply with these digits, right? And if there is a radix point, so after that you have to take reciprocal of this base, right? Okay, so one of the very important question can be asked in the gate examination. In fact, suppose they will ask you 3 to 5 is given and the base is x, right? The base is x. Okay, if they will ask you what is the base, right? So base is x basically, so how can you write this as 5 into x to the power 0 plus 2 into x to the power 1 plus 3 into x to the power 2. Okay, so this can be written as, you will get some polynomial here, 3x square plus 2x plus 5, right? And this will be in base 10, right? So if someone is going to ask you what can be the base here, the maximum base what can be, so you can see here inside digits are 5 to 3, right? The maximum digit is 5 here, so the base cannot be greater than 5, remember always. Okay, I mean the base must be greater than 5, sorry, cannot name, base must be greater than 5, right? Because the base should be always greater than the digit, right? Base must be greater than digits. Okay, so if maximum digit is 5 here, so base must be greater than 5 only, right? So remember always, greater than 5 means you can say equal to 6 or greater than 6, it can be, right? So the base can be equal to 6 or greater than 6. Okay, depending upon the options given you can choose, right? So always keep in mind, right, your digits cannot be greater than this base, okay, of the number system. Remember, this is what the important concept. Question can be asked from these concept, right? Okay, moving forward, okay, moving forward here, hexadecimal to octal. As I told you, if you're going from hexa decimal, right, to octal, okay, what you can do here is, you have to convert hexa to hexa, then there will be one intermediate step, that is in binary, right? And then you have to convert into, okay, suppose hexa is given in 16, so you have to convert into binary, then Okay, so this is what the intermediate step is. Okay, the intermediate step. Okay, directly you can't jump, right? This is wrong, this is correct, like this. So if you're converting from hexa to binaries, you know that you have to take 4 digits, right? Each hex must be represented by 4 digits, and if you're converting from binary to octals, you have to take what? Group 3. Okay, you sorry, this should be bit, right? Not digits, this should be bit, 4 bit. Okay, this is what the step is and nothing else. So let me take one example to explain you. So 2b E16. Suppose this is given in in hexa, so what you have to convert into octal. So what you have to do here is 3BE, okay, which is given in hexa, so you have to convert into, so E means what? E means you can write E, right? So A is 10, A 10, B is 11, 12, 13, right? C, D, E, that is 14, okay. So 14 means what? 14 means 8421, 8412 plus 2, right? So 1110. So it must be written 1110, right? Next you can represent B. B is 11, right? So B is 11 means this must be, this must be, this must be, right? So 1011, 1011, and 3, right? So 3 can be represented with 0 0 0 1 1, right? 0 0 1 1. Now what you have to do here is you have to group 3 bits, right, from the right to left. So this is what one pair, this is what one pair, right? I mean okay, this is one group, this is one group, right? So this will give you 1 6 7 6, okay, in octal. So this is very easy, anyone can do, okay. I'm just touching here and this is gonna be very easy, right? And octal to hexa, the same procedure, right? Octal to hexa, hexadecimal, right? Means octal is given, you have to convert into distance. What you have to do here is you have to take octal, then convert into this, and then convert into this. Guys, remember always you can't jump from this to this, right? You have to go like this always, okay. Keep in mind this, this is preferable, this is wrong, okay. I mean there is no any method which can help you to convert octal to hexa directly, right? Okay, so this is going to be one intermediate step. Right. Suppose example I'm gonna take here is 367, okay, and the base is 8 here, right? And you have to convert into hexadecimal number system, right? So what you have to do here is you can see. So what you have to do here is you have to take 3 bits, for each digit. As I told you, 7 can be represented by 111, right? And 6 can be represented by 011, or sorry, 110, right? And 3 can be represented by 011, okay. So this is 8, sorry, this is in binary, right? Now you have to group 4, right? 4 digits. So this will be, here you can take 4 0 0 0, right? So this is going to be giving you 8421, right? This is 7 here, and next one is F. This is F, okay. F7 will be the right answer for this question, okay. Now let us take one very important problem, right? Because in the revision, if we will take problem as well, you will understand better, right? Concept plus followed by the problem. So you have to keep these two important methods how to revise any subject, right? So for these subjects, this is how we are revising, and for any other subjects you can revise like this, okay. So concept followed by the problem, concept followed by the problem, right? so that it will help you to recall. Okay, so problem is like that. Find the minimum decimal value, right? Find the minimum decimal value of 32cx. 32cx. Okay, so the step one, how we are going to solve here is solution. So remember that what is the highest digit here, what is the maximum digit here? C, right? So remember that as digit C is given, right? C is given, so what can be the base, right? So the base must be greater than C, right? I mean C is what? A, B, C, 10, this is 11, this is 12, right? The base must be greater than 12, right? The base can be 13, base can be greater than 13, right? So the base can be what? From here we can judge, right? We can anticipate the base of the number system can be 13 or greater than 13, right? So your step number 2 will be after this. Okay, this is the first observation you have to keep in mind, right? You have to do the first observe. The moment you see the question, you must be able to make a wonderful observation like this. And if you are perfect, see, the base is always greater than the digits given in this number system, right? So as digits, the maximum digit is C, so the base must be greater than 13, right? Okay, it cannot be 12. So now what you can do here is 32cx. So you can expand this now. So in the base decimal number system, right? Because decimal value you have to find minimum decimal value. So you can expand in decimal number system. So what you can do here is that is C means 12 into x to the power 0, right? 2 into x, okay, plus 3 into x square, right? And you can add them. Okay, so this will give you one polynomial again, 3x square plus 2x plus 12, right? So from this polynomial you can observe that the maximum value is 12. The base of this number system must be greater than 13 or equal to 13, right? Okay, so you have to find the minimum decimal value, right? So the minimum base can be 13. So in place of x you can plug, now in place of x you can plug what x10 minimum, right? So what you can do here is 3 into 13 to the power 2 plus 2 into 13 plus 12. Once you will do here the calculation, right, I think 3 into 169 plus this will give you 13 twos are, right? That will give you what? 26, right? Yes, and this will give you 12, right? So what you can do here is you can add, right? So 3 nines are what? 27. Okay, and you can use calculator, I don't have any problem. 3 nines are 27, and okay, and 3 6 are 18 plus 2 22, 3 1s are 507, right? Okay, you can calculate, you can use the calculator here. I'm just using calculator for the time being, and okay, just to verify everything. Okay, calculator, yes. So this will give you what? 3 into 3 into 13 into 13, right? 507 plus 26 plus 12, right? So you can add these, okay, plus 26 plus 12, it will give 545. Okay, maximum value it must be 545. Okay, this is how we can calculate. Okay, so we found out the minimum base, and this is the max minimum okay, minimum decimal value. Suppose the problem given here is that next problem, like 1 0 1 1 1 0 dot 1 1 1 0 1 1 1, right? And they are asking you to convert into hexa, right? They are asking you to convert it to hexa. So what you have to do here is you have to group 4 digit here, and if there is less number of bits, okay, so you can append extra bits, right? 00. So this is E basically, right? And this is 2. Okay, this is 2. So you have to go like this, and for after radix, point, you have to go like this from left to right, and here from right to left. Okay, so this group 4, okay, this will give you B. Okay, and after that you can again plug 000, right? So this will give you 8, right? So this is how we can represent X, I mean this binary representation in hexa. So this is 2E dot B8, okay, in hexa. Okay, so I hope this is clear for everyone. Now next problem, let us take next problem here. The problem next is find the number of ones, right? Find the number of ones, right? Find the number of ones in the binary representation system, in the binary representation system. Okay, representation system. Okay, so you have to find the number of ones in the binary representation system. So suppose this is given in decimal, right? That is given as 3 into 4096, okay, plus 5 into 256 plus 1. Okay, this is given, and you have to find okay, representation of the decimal number. Sorry, question is incomplete here. Find the number of ones in the binary representation, right, of following decimal number, right? Following decimal number. This is the question. Following decimal number. So by 10 equal to what? 3 into 10, 4096 plus this is given, right? So the very first idea what comes in our mind is you have to take this, right? So here you can write as 3 into 16 to the power 3, right, plus 5 into 16 to the power 2, plus this can be written as 1 into 16 to the power 0, right? So 0. So basically you can convert into hexa, and then hexa. So these are the hexa bits. Okay, these are the hexa bits now, right? This is the hexa bits. So by 10 can be converted to hexa, that is 3 5. Okay, and one bit is absent here. You can see here there is no 16 to the power 1, so one bit is absent, so you can write is at 0, right? I mean 0 into 10 raised 16 to the power 1 should be there, right? So 350, and this is 1. Now you can convert into binary and count the number of ones, right? So converting into binary means you have to take 4. Each hexa digit should be represented by the 4 number of bits. So 1 can be represented by what? 0001, right? And your 00 can be 000, right? 5 can be represented by 0101, and 30011, right? This is how. Now you can count the number of ones, right? So 1 2 3 4 5. So the answer for this question is gonna be 5. So this is a very easy question. You have to make wonderful observation, right? So before attacking into the problem, observations are very important, right? Okay, intuitively you have to solve questions, right, in order to save time. Okay, so next very important concept which I'm gonna talk again is with the help of problem, right? So find the number of bits, right? You have to find number of bits, okay, required to represent the following decimal number, right? Required to represent okay, the decimal number in binary. Decimal number in it. Binary means what? The base is 2, right? So this must be like 2 to the power n, right? 2 to the power n must be greater than 7683, right? So now you have to find the value of n, right? Now you have to find the value of n. So I will give you the trick here. I will give you the trick, okay? I will give you the trick, okay? So it requires n equal to 13, okay? Without using calculator you can find, right? So the trick here is what? Trick here is very easy, right? In fact, this will also help you to understand the memory size, okay? Semiconductor, I mean memory size when we will talk about ROM, RAM and all, right? So 2 to the power 10 is what basically it is basically 1k, right? And this is represented to 1024, right? We must be familiar with this, okay? 2 to the power 10 means 1k, right? And 2 to the power 10 means 1024, right? 1024. You have to keep in mind these numbers. And when 2 to the power 11, right? So you can multiply with 2 here, right? So it will give you 2048, right? And 2 to the power 12 means you can multiply with this, right? So it will give you 4096, and 2 to the power 13, right? So it will give you 8192, right? So in the question they have given what? In the question they have given, in question, right? What was given? It was given 7683. So you have to always check this decimal number is closer to which decimal number, right? So it is closer to this, right? So your answer will be what? 13, right? Your answer will be 13. This is a very important concept which you have to keep in mind, okay? In case of kilo, 2 to the power 10 means 1k, okay? And suppose 2 to the power 20 is given, right? 2 to the power 20 means what? 1 mega, right? 2 to the power 30 means what? 1 giga, right? 2 to the power 40 means what? 1 tera, right? 1 tera. So these are the big data now. 2 to the power 20, 1 mega means 10 raised to power 6, okay? 1 mega, 10 raised to power 6, right? 1 giga means 10 raised to power 9. 1 tera means 10 raised to power 12. This is how we represents. So very easy, that's it, right? So if they will ask you the question like if there is decimal number system, right? 10 raised to power 6, and how many, how many bits are required, how many bits are required? What you can do? Number of bits, okay? So that is 1 mega, right? Means 20 bits are required. 10 raised to power 6 means what? 1 mega means 2 to the power 20, right? Means if you compare 2 to the power n, so n equal to what? 20 bits. This is one method, right? This is one method. Needless to use calculator and all, okay? And you must also know that 10 to the power 3 is equal to what? 2 to the power 10. Okay, this is approximately equal to 2 to the power 10 only, right? So this is how, so you can square both the sides. 10 to the power 6 will be equal to 2 to the power 20. Okay, these methods, okay, these are the methods I'm telling you, method 1, method 2. Okay, right? And you can also directly calculate if you are not smart enough, okay? And so this is method 2 for everyone, okay? This is general method I'm telling you now, okay? I'm now telling you the general method. Now I'm telling you the general method, right? Let me check the comments. Okay, the general method is what? General method is like, suppose you have to find the number of bits to represent this decimal number, that is 10 raised to power 6. So you can compare 2 raised to power n must be greater than 10 raised to power 6, okay? So now you can take the log both side, right? Take log both side, right? Take log both side. If we are not smart, so we will do like this, okay? So take, so n log base 10, okay? is greater than, right, is greater than what, 6 log 10 base 10, right? So it will be what, it will be equal to 6. Okay, now what you can do here is n equal to what, n equal to, or you can say n greater than is 6 by log, okay, base 10, that is 2. So now equal to, you can write 6 upon 0.301, it will give you 20 bits, okay, approximately. So you can do like this, or okay, so suppose there is a n numbers, n bit is there, so what is the range of the number you can represent in okay, so it can, you can represent from 0 to 2 to the power n minus 1. Okay, means maximum decimal number will be what, decimal value will be 2 raised to power n minus 1, minimum will be 0. Suppose number of bits are 4, so you can represent 0 to 15, right, n equal to 8, so you're going to represent from 0 to 2 raised to power 8 minus 1, means 255. Okay, this is how you can do. Okay, suppose you are getting like this, 2 raised to power n greater than 19.06, so n equal to 20 should be there approximately, right? So always take like this, higher. Okay, higher the bit you have to take. Yes. Now what you have to do here is one very important question. Let me take one important question again. Find the base of the system, right? You have to find the base of the system. Find the base of system. Okay, if they will give you base of system and they will give you question, in fact in aptitude also this can be asked. Suppose 47 plus 34 equal to 80, you have to find, I mean this is given and you have to find the base. Okay, what is the base? With the help of that base you have added these two numbers. So what you can do here is you can consider, let the base be, let be the base what, b, right? And now what you can say, 47b plus 34b equal to 80b, right? This is how you can write. Okay, now what you can do here is you can open it, right? So it can be written as 4b plus 7 plus 3b plus 4, I mean b to the power 0 means 1 only, so 8b plus 0. Okay, now you can take b, I mean this side and that side, right? This is very easy now. So 7b and that side it goes, so it will be 1b, right? So 7b plus 11 equal to 8b, b equal to 11. So this is going to be your answer for this question, right? Simple algebra. Okay, now let us calculate, let us take one problem again. Okay, and you have to find the base here. Suppose 302 upon 20 is given, right? And you have to find base, and they have given it is 13.1, right? What they are asking here is you have to find the base. Find the base. What you can do here is you can consider base b here. So this is b, b, and this is b. So now what you can do here is you can write like 3b square plus 0 plus 2 upon 2b equal to what? It will give you b plus 3, okay, plus, it will give you what, after decimal, after radix point you have to take reciprocal of this base, so it must be 1 by b. Now what you can do here is 3b square plus 2 upon 2b equal to b square plus 3b plus 1 upon b. Now b gone, this b and this b gone, and you can multiply like this, right? So what you can do here is you can write here is that after this step. Okay, 3b square plus 2 equal to 2b square plus 6b plus 2. Okay, now you can take this b square this side, so b square, I mean this b square and this minus 6b, right, and these 2 and these 2 cancel, equal to 0. It will be b times b minus 6 equal to 0. So b equal to 0 and b equal to 6. B equal to 0 means what? It cannot be the base b. So for this representation, the base must be equal to what? 6. So this is how we calculate, right? In the examination, this is how you have to do. Okay, within 10 second, 20 second, you can do how to find the base and all. Okay. Now let us take one very important problem. In fact, last year also this kind of problem was asked. So find find the possible value of value of x and y, right, in the following. Okay, so in the digital circuit problem, you cannot anticipate that this formula is gonna be useful, right? You have to give some time to solve digital circuit questions, right? I mean, a logical way of thinking is required. It is not like that, okay, you have to apply KVL, KCL, certain sets of rules and laws. Okay, you have to analyze. If you will skip the logical part, logically, the way one analyzes the problem, right, you will not be able to get the right answer. So my suggestion would be, whenever you solve this circuit problem, you have to give your logical thinking. Sir, okay, will you explain encoder and decoder? Yes, actually I'm planning, but I don't know whether I would be reaching to that point, because already the number system is taking a lot of time. I will conduct session, don't worry. How many 32K into 1 RAM chips are needed to provide memory capacity of 256K bytes? Okay, so Sai Kiran, I will be talking about this question, right, when we will reach to memory, right? So I have given you the basics here, right? So you can I'm just talking about the basics of number system right now. Okay, so I cannot directly jump to that concept, but yes, I will definitely answer, right? Okay. Yes, yes. So how to find memory capacity, we will talk about that. Okay. Mm. Yes. So okay, let us focus on this question. Okay. Find the possible value of x and y in the following. Right? Find the possible value of x and y in the following. So suppose in the question they have given that 49, right? 49 x minus 1 is equal to 35y. 35y. So okay, so now you have to find the possible value of x and y here, right? So x minus 1 is the base of this, right? The maximum digit is what? 9. The maximum digit is 5, maximum digit is 3, right? So the base must be greater than 5. Base must be greater than 9, right? In fact, must be greater than 9, right? Or 10. 10 it can be, or greater than. So the step number 1 is what? Step number 1 is x minus 1 must be greater than 10. Okay, means x must be greater than 11, right? Okay, and in this case you can say that the base by must be greater than 6. So this is what two important conclusion we have got, right? Means x must be greater than 11 and or equal to 11, and by must be greater than 6. Okay, now what we can do here is you have to go for step number 2, right? The step number 2 is what? Step number 2 is this: convert LHS, RHS into decimal, right? Okay. So in the combination circuit part, Sai Kiran, we will definitely talk about encoder and decoder, and they are very easy topic, right? You don't have to take any topic as complicated as, right? They are not complicated, only our perception is there ki, oh, these topics are very tough, right? So let us go step by step, okay, and we will try to conclude everything, right? But this is the number system and quick revision of this circuit, right? So what I'm doing is I'm not only touching the concept, I'm also trying to tell you the problem, how to solve the problem, right? Because in the gate examination, this plays an important role, how to approach to the problem, right? Convert LHS and RHS into decimal. So how you can convert 4 into x minus 1 to the power 1 and 9 into x minus 1 to the power 0 is equal to 3 by plus 5. Okay, so this can be written as 4x minus 4 plus 9x equal to 3 by plus 5, and this will be equal to what? This is 4x equal to 3 by, right? How? Because this 4 will go that side, okay, and okay, this x will not be there, so this will get cancelled. You got 4x equal to 3y, right? So you have to choose the x and y which can satisfy this equation 4x equal to 3y, right? So let us take x and y values. What are the possible values you can take here is, so if you are going to take first of all, x must be greater than what? X must be greater than 11, right? This guy must be greater than 11 and this guy must be greater than 6. So we can take 11, right? So if you're going to take 11, right, and if you're going to take 6, so they will not be equal. Okay, so let us take 12 and 16, 15 and 20. Okay, so 12 into 4, 48, and 16 into 3. So these are the values, set of values which are possible for this x and y, right? 15 and 20, 30 and 40. Okay, so depending upon the options you can choose. So I think in the gate 2021 also one question was there based on this, right? So please make sure this is how we solve the question. Okay, one more problem we can take here is 75x equal to 45 by, right? So step number one is what? Step number one is the maximum digit is 7, so x must be greater than 8, right? Okay, and by maximum digit is 5, so by must be greater than equal to 6, means it can be 6 or greater than 6, not equal to 5, remember, or less than 5. Okay, right. Now what you have to do, the step 2. What is step 2 here? Step 2 is basically nothing but the convert LHS and RHS into decimal, right? So decimal you can convert, right? Okay, so this is 7x plus 5 equal to 4 by plus 5. Again you have got one equation, 7x equal to 4 by, right? So choose x and y accordingly, right? And so you can find the best combination like 8 and 14, 16 and 28. Okay, so you spend couple of minutes, you will get the answer, right? So do not skip this kind of a question. Okay, now we'll not take many problems, right? Okay, now what we have to do here is as we know that how to add two numbers, right? We know how to add two numbers, so we will skip this part, right? How to add two numbers if it is having the base 5, hexa or octal, right? So these kind of questions, please think about it. Okay, Right. So this is what I want to discuss okay. Now what we will do here is you know we'll take and in fact we will conduct again the next session, okay, because the session will be very long, right? So we'll again come and talk about complements and everything, right? So let us divide these sessions into different chunks, right? So I hope you might have understood these basics. We'll meet again, talk about complements, right? And the one's complement, two's complement, definitely question will be there, right? And we will talk about and around carry concept, right? EAC concept, okay? And okay, and we'll see the sign number like one's complement form, two's complement form, right? Definitely you can expect questions, and maximum range of representation of digital numbers, right? Binary numbers in two's complement, one's complement. Okay, so you can expect question from here. My session will be on complements, okay, in the next session. And then we will talk about binary codes, okay? We'll talk about binary codes as well, okay? And like VCD and VCD is addition, subtractions, access 3 codes and all, okay? And code converters as well, we will see the binary to gray code converters and all those things, right? And then we'll go to basics, right? So thank you so much. We'll meet in the next session. Thank you.